Hi, everybody. I'm Jinhua Zhao, Professor of Cities and Transportation at MIT. Welcome to the MIT Mobility Forum, designed by the MIT Mobility Initiative. Today's topic is Transportation Megaproject, Global Hits and Misses. Megaproject often carry an impression today of over budget, over time, and also seen as the white elephant. But there are actually successful examples globally. Why can China build 45,000 kilometer of high-speed rail in the last 20 years? What can we learn from bus rapid transit in Latin America and Southeast Asia? What are their practices and what are their outcomes? So today I really have the great honor to have Professor John Landis join us, presenting his recent book, Megaproject for Megacities, a Comparative Casebook, and discuss the 7 do's and do nots for undertaking successful transportation megaproject. Before I formally introduce Professor John Landis, I would reiterate the norm of today's forum, that is everyone contribute an idea, either in the form of comments or a question in the chat here. We just did the warm up for your organization, city, and local time, but I'll do another one quickly. In the chat, if you can type in what's your favorite mega project in the chat, right? To see that which of the case studies John may already written in the book, to get a flavor. What is your favorite mega project? Whatever we define favorite, right? The favorite best, the favorite you want to criticize, whatever you define. Just get a sense of what are the project you've been aware with, interested in doing that. John Landis is the Emeritus Professor of City and Regional Planning at the Weissman School of Design at the University of Pennsylvania, where he served as the department chair of the Department of City Planning for 10 years. John's current research focuses on the relationship between planning practice, urban innovation, and entrepreneurship, and the successful urban development outcome. He wrote the book, Megaproject, which we'll present today, but also a few recent articles on why American planning needs a more entrepreneurial practice modality, the 50 years of local growth management in America, etc. So please join me, welcome Professor John Landis. John, please.
Thank you very much. Can you all hear me?
Yes.
Great. I want to make sure my volume's correct. It's a pleasure to be back at MIT, even virtually. Many of you may or may not be aware, I see a number of familiar names out there, that I was actually an undergraduate at MIT back in the early 70s, and not a week goes by in my professional and life when I don't look back and give thanks for the terrific education I got at MIT. I started off in course 11, then quickly made my way over to course 1. And then after 4 brutal Boston winters, moved out to UC Berkeley. Let me see if I can share my screen. Let's see, got a lot of things up. Let's see. Okay, can you all see that? Is that working?
Yes, very well.
Okay, great. Well, I started this book, as I was saying, in 2020, finished it in 2022, was very fortunate to rope in a lot of terrific authors from around the world to talk about their experiences and their studies of different mega projects. And I learned a lot from them along the way, and I hope to share some of those lessons today. Okay, so most of you are probably start from what is the conventional wisdom about mega projects. A lot of it, at least in America, here in the US, stems from a very important book done by Alan Altshuler at Harvard in the early 2000s called Megaprojects, The Changing Politics of Urban Public Investments, which was a review of megaproject experience in the US, really focusing on the big dig, and was quite critical and said that we're really at the end of the megaproject era here in the US. Just a little aside, I actually worked on the big dig when I was an undergraduate at MIT at an organization called the Central Transportation Planning Staff in Boston. And I remember the then governor, Michael Dukakis, coming by to look at the results of our transportation demand models and all. So I have a long link back to this. Many of you have also probably heard from Ben Fluberg, who is a mega project skeptic and who in 2014 coined what he called the iron law of megaprojects, which is that they are always over budget, over time, under benefit, and over again. We keep making the same mistakes over and over again. So what I want to do today is be a little more nuanced in my consideration of megaprojects. Hopefully in 25 minutes, I'll talk about why they're so appealing, as well as why people criticize them, talk a little bit about the book, review the 4 eras of megaprojects, really focus on 4 transportation megaprojects up close, and then finally conclude the 7 secrets of megaproject success. So let's see. Okay, megaprojects pro and con. First of all, we need to define a megaproject, and here I'm using the definition from the Oxford Handbook of Megaproject Management. Megaprojects are large-scale, complex ventures that typically cost $1 billion or more, take many years to develop and build, involve multiple public and private stakeholders, generate potentially transformational impacts, and affect large numbers of people. This was the definition in 2017. I suspect the cost threshold these days is probably about $1.5 billion before you can be considered a mega project. Why do people want to do these? Well, in theory, they offer a lot of advantages. They're planning efficiency advantages by focusing on large areas and treating large areas. Their construction and design and engineering advantages by thinking about large systems all at once. They're particularly financing advantages and efficiencies about spreading risks over larger scales and larger numbers of beneficiaries. Their benefit capture and equity advantages potentially to them. There are opportunities to intervene in ways that promote greater resilience and sustainability. And finally, in terms of operating, there's some network advantages. So in theory, we ought to be able to provide infrastructure services more efficiently and equitably by megaprojects. But at the same time, there are potential downsides in considering them. If we use the wrong discount rate, we may approve megaprojects that don't make sense. As we're going to see, there's not a lot of project management experience out there doing megaprojects, which shows up in a lot of failures. There are often a lot of embedded conflicts of interests among stakeholders, some of whom are interested in very different goals that often conflict. There's a lack of learning opportunities because you're doing one big thing all at once. The market and financial analysis that's been done to back up megaprojects is really often quite suspect. There's a particular vulnerability to low probability but high cost events known as black swan events. And lastly, very few people like to hear that they're doing things wrongly or that there are problems, which create sort of feedback bias effects and learning effects. And all of these issues have been enumerated and illustrated very well by Ben Fluberg in his work. What I wanted to do was look at those. Oh, I should say that these advantages and disadvantages haven't really affected interest in megaprojects. Here's just a series of panels that shows you how megaproject activity over the last 40 or 50 years organized. The first panel shows metro starts. The second panel shows high-speed rail lines. The third panel shows hydroelectric dam capacity. The fourth project on the lower left shows airports. Fifth project, long span suspension bridges. And lastly, railroad and railway tunnel projects. And you can see that interest in these things goes up and down. And since the 1990s, interest has gone really up, particularly focusing on China, which has done a lot on rail and high-speed rail and urban transit projects, but also particularly dams and hydro generating. So if megaprojects are going out of style, at least in the US, the rest of the world hasn't seemed to have heard about that. And interest in megaprojects remains pretty high around the rest of the world. Now, if you think about the future a little bit, most megaprojects that are out there or being proposed are to provide services of all sorts to city dwellers or people who live in urban areas. That's one thing. And the other thing about megaprojects is they usually have to be financed by, not necessarily completely, but to some extent by their users. So in order to take on megaprojects, the market for megaprojects, looking forward, you probably want to think about a certain amount of urban growth, and you want to think about a certain amount of financial capacity or wealth. And so what I did with this graphic is just looked at projected urban growth over at the time, the next 10 years, and looked at financial capacity or income capacity in terms of per capita GDP. And I found that sort of dividing line here, that's sort of the dotted line, between countries that are going to grow a lot versus not going to grow a lot in terms of their cities. So you can see Russia's probably not going to grow a lot in terms of its cities, but China and India, and to a certain extent, the United States certainly will. And also the United States and China have the GDP and the wealth to take on financing mega projects. Whereas when I did this, countries like India and Indonesia sort of fell below the line. Countries like Germany, South Korea, and Japan are not growing, at least not a lot, but they have a lot of financial capacity. And so I think there's a large market looking into the future for mega projects, and I expect to see them continuing to be popular. With that in mind, I wanted to look and see if, rather than saying, oh, have an iron law of mega projects, I wanted to see if we could develop a series of case studies that related good practice to good performance, and conversely bad practice to bad performance. That is, it isn't all, they just aren't all good or bad, but mega projects exist on sort of a continuum that links practice with performance. Practice includes planning, design, engineering, financing, construction, especially project management, project delivery, and project operation. And I looked at a number of performance measures, particularly goal achievement, benefit generation, synergy generation, positive externalities, and avoidance of social costs, and promoting sustainability, resilience, equity. And lastly, the potential for particular projects to offer transferable lessons for other people considering and places considering mega projects. And so each chapter in the book ends with a series of practice lessons and takeaways that are designed to improve performance. I wanted to, how did I choose the case studies that we looked at? Well, I wanted them to embody bold ambitions. I wanted them to be relatively contemporary. I wanted them to be urban oriented, although many happen between cities. I wanted to consider diversity of project types. I wanted to have them be geographically representative. The previous mega project literature has mostly been Anglo-American in its orientation, and I want to go beyond that. I wanted them to include notable design or engineering features, diverse financing forms. I needed good documentation. I wanted to study a diversity of outcomes. I think that was the most important. I wanted to see good projects, bad projects, and everything in between. I wanted to be able to construct clear narratives about causes and effect. And lastly, I wanted diversity of takeaways. And this led me to 13 sets of mega projects. And I'm going to talk about 4 today. 4 urban transportation projects, including 2 I'm going to talk about today, London's Crossrail and China's high-speed rail. So if you tuned in for BRT, Bus Rapid Transit, I think you're going to have to look at the book. 2 bridge and tunnel projects. Today I'm going to focus on Seattle's Alaska Way Viaduct Replacement Tunnel. 2 airport projects, and I'm going to give you a twofer today on that. The Berlin-Brandenburg Airport and the LaGuardia Terminal B construction. So the ones in red are what I'm going to talk about today. The book also looks at 3 urban development projects, Canary Wharf in London, Hafen City, Hamburg, and Songdo International Business District in South Korea, and 2 sets of park and energy projects, Brooklyn Bridge Park in New York City, and various renewable energy projects around the world. And from the map, I hope you can see I mostly, but not completely met my preference for geographic diversity. The big stars show you places of multiple mega projects, but the little ones, they're projects in South America, they're projects in Europe, they're projects in Asia, and of course, they're projects in the United States. So I hope this geographic diversity lends a certain amount of transferability. Before we look at the 4 case study projects, let me just organize the past for you, I think about megaprojects as having happened in four eras. The era between 1825 and 1915, which was all about transportation megaprojects to promote commerce and trade. The era between 1935 and 1995, in which the field of megaprojects was really focused in the United States. The area between 1964 and 2016, in which megaprojects went global in a big way, starting with the Shinkansen in Japan. And lastly, the current era, in which the lead in megaprojects really belongs to China. Very quickly, here's that first era. It started with the Erie Canal, which was the first modern megaproject. What makes it modern? It was engineered. It used new technologies, and particularly gunpowder to blow up the earth to dig out the canal. It was publicly financed, and it was intended to expand commercial market and serve a broader populace. And that really made it different from previous projects, which may have had one or two of those characteristics, but not all four. It was followed up by the Suez Canal in the 1860s, the U.S. Transcontinental Railroad in the 1860s, the Gotthard Tunnel. Somebody, I think, mentioned that as their favorite mega project. And that was the first Gotthard Tunnel. There's actually a second one. And the Trans-Siberian Railroad in 1904. And finally, the Panama Canal, which really marked the rise of the beginning of America's predominance in the megaproject era. And here you can see the Erie Canal in the graphic. It was an amazing project for the time, 363 miles long, 40 feet wide, 36 locks. It basically meant it enabled the amount, the freight that you could transport long distances to go from packets of 10 and 20 pounds to cargo shipments of hundreds of pounds, which really the Erie Canal, more than anything else, was responsible for the opening up of America in the early 19th century. And ultimately, the fact that New York City, by linking to the middle of America through the Hudson River Canal, New York City's ascendance over its chief rival, which is where I live at the time, Philadelphia. So Erie Canal is extremely important. The 1930s to the 1990s were really America's era of mega projects, brought on by the Bessemer Steel Revolution, which allowed to create the building of suspension bridges and skyscrapers and all manner of things. If there's probably the most important mega project in history is the Hoover Dam. Planning began in 1928, construction finished in 1936, but really construction only took 2.5 years. The Hoover Dam, and you can see the picture in the lower left, while under construction, was 50% taller and 150% more capacity than any dam that had been done previously. In planning the Hoover Dam, they thought it would take 4 years to build it. It ended up taking 2.5. They anticipated hundreds and maybe even 1,000 fatalities because of the way dams were built. They had less than 100. But most importantly, it represented an industrialized approach to mega project construction rather than sort of a human-centered approach. Other big mega projects, the U.S. Interstate Highway System, the Tennessee Valley Authority, BART, MARTA, and Metro in the 1970s, which were meant as a reinvention of commuter rail for the automobile era. The Battery Park City in New York, the largest Newtown project in history of the United States. And then finally, the Big Dig, which, as many of you have noticed, really marked the end of an era. The pictures show the U.S. Interstate Highway Network is originally conceived. Picture D is, I'm not sure why it's D, is the tunnel underneath the tunnel section underneath the San Francisco Bay that was sunk to be used by BART. And the last picture shows you Battery Park. As I said, mega projects were really an American thing until the 1960s or 1970s, when with the opening of the Tokyo Olympics in 1964, Americans got to see something they'd never seen before on satellite TV, which was the bullet train. Up until then, people thought only Americans could do mega projects, but the Japanese with the Shinkansen bullet train, the first one you can see there in picture B, really opened up, made it clear that mega projects were going to be undertaken in lots and lots of places. And I highlighted the Shinkansen bullet train for its pioneering, for the way it changed the way people thought about mega projects. But another one that came a little later in 1969 was the Mexico City Metro. Previously, metros had been built for middle-class commuters. Mexico City Metro was the first metro in the world really built for lower-income commuters. And it was a tremendous success that way. You can see other examples that somebody mentioned, the tunnel. This is the new Gotthard base tunnel, not the old one. Of course, the TGV. Probably the first modern mega project outside the US was the Delta Works, constructed in the 1950s all the way to the 1970s, a series of flood control projects in the Netherlands, both levees and dams and the like. So you start to see the world of mega projects really expanding. And the most recent area, of course, has been the Chinese era, the Three Gorges Dam, Beijing's Capital International Airport. Some of you probably seen these in person. The Shanghai metro system. In 1990, Shanghai didn't have a single, or maybe it had one metro line. Today, it has the most metro kilometers of metro line of any system in the world. And they did that in 20 years, which is pretty amazing. And finally, even more impressive, China's high-speed rail network, which for all intents and purposes didn't exist in 2004, still didn't exist in 2007, and by 2018 had 25,000 kilometers of high-speed rail line. It's an amazing achievement. So let's look at a little bit of these projects up close. I'll quickly go through the four that I want to talk about, and with the lessons, things that went right and things that went wrong. Here's China's high-speed rail network as of 2021, about 37,000 kilometers. It's what they call the 8x8 line system, 8 north-south lines, 8 east-west lines. It was, there are two train classes, some that, one set that goes between 300 to 350 kilometers per hour, a slower set that goes 200 to 250. 2019, before the pandemic, they recorded 2 billion passengers on high-speed rail, which is 3 times the number who traveled among the same cities by air, and 13 times the number of passengers in terms of passenger kilometer miles as Japan. On many legs, it cut rail travel times by 2/3. The most highly used line from Beijing, it cut the travel time from 10 hours to 4 hours, cost about 630 billion. It went from, as I mentioned, it only took 4 years to go from funding authorization, 2004, to the opening of the first line in 2008, and only took 16 years to get to 37,000 kilometers. The theory of the high-speed rail line in China was really good, and that was that it should hit the sweet spot that goes between 200 and 1,200 kilometers of intercity travel. Less than 200 kilometers, cars dominate. Above 1,200 kilometers, planes dominate. But between 200 to 1,200 kilometers, door to door, high-speed rail is very, very competitive. The other things, the reasons it's worked very well in China is because of their technology transfer model. They basically said to the European companies that built high-speed rail vehicles, and on the lower left, you can see those 4 companies. We will buy train sets from you for the next 10 years to put on our rights of way. After that, we're going to own the technology of those train sets. 3 of the 4 companies originally agreed to those conditions. A 4th did not. When the size of the market came around, that 4th company agreed too. So China basically bought the train unit technology and then did something very important. They reverse engineered it and proved it themselves. And today, China is the biggest exporter of high-speed rail train units. They also developed a very strong domestic engineering and manufacturing expertise. During the global financial crisis, they doubled down on construction. China's big secret is their level of standardization. Roads, bridges, rights of way, everything is standardized, regardless of where you are. Even the terminal stations, although they look much different in terms of their internal workings, are pretty standardized. And this allowed them not only to build the system with incredible speed, but also much more efficiently than other similar systems. Cost about 40% on a sort of per mile basis to build China's high-speed rail system as Spain or France's. And lastly, they had a very capable and driven project management team. What went wrong? Not so much. There was an accident early on based on some poor signaling technology, but they recovered and learned from that pretty quickly. The other minor disappointment is it was thought that creating high-speed rail would do a lot for some lesser economically for some lesser cities in central China. It doesn't seem to have had that effect. Each of the mega projects I'm going to show you, I went through and sort of rated them on a scale of 1 to 4 and how well they performed. And so here's China's high-speed rail. It achieved its goals and objectives in a timely manner. It used appropriate and cost-efficient technologies. It avoided significant planning, engineering, and construction delays. It did very well in some other areas, and it got a total score of 29, or about 73% of what the maximum possible score. It's a terrific success story, even though there are some issues about transparency and things like that. I want to move quickly from China to the US. This is the story of Seattle's, the tunnel under Seattle's harbor. There's a sort of a rendering of it. I'm very fortunate to have wonderful co-authors, Jan Whittington and Molly Riddle from the University of Washington, who did most of the work on this chapter. I don't know how many of you know about this project, the Alaskan Way Viaduct Replacement Tunnel. It was begun in the early 2000s because there was an elevated highway that was damaged in 2001 Nisqually earthquake. And when they looked at fixing it, it just seemed tremendously expensive and would still be vulnerable for earthquakes. So they said, we've got to do something about this. And so they for about 5 or 6 or actually 7 or 8 years, they batted around a bunch of alternatives, including a tunnel replacing the elevated highway, including a boulevard at the surface, including a new elevated highway. And they went back and forth, and they didn't present it to the public very well. The work was the project sponsor was Washington State DOT. And then finally, there's sort of a breakthrough in 2010 when the engineers and the planners said, hey, wait a minute. Previous tunnels have always been small diameter side by side. How about we build a single large diameter stacked tunnel? And you can see a picture of that, where one direction is on top of the other. And by doing so, we can do this quickly at a higher capacity and cheaper. And so after several years of planning, they went for this idea of a single large diameter stacked tunnel. Only one problem. There were no boring machines that could bore out a tunnel that large, that wide. The lower right hand shows you the previous boring machines. By the way, many of you may know that by tradition, boring machines are always named for women. So they commissioned the leading boring company and manufacturing company in the world, which is Germany, to build Bertha, which is 57 feet in diameter. Construction started in 2013. And almost immediately, Bertha hit a metal pipe that was undocumented, and its bearing was just burned out almost immediately. And unfortunately, nobody anticipated that, and there was sort of no way to retrieve the machine, it had to be disassembled under the ground and then shipped back to Germany because there were no replacement parts for it, and rebuilt. And it took about 2.5 years to do that. But other than that problem with hitting that pipe, that project went pretty well. So what went right? They had a good project management. They had a very good partnership process after 2017 that involved this various stakeholders. And I think most importantly, they saw this as an opportunity to redo Seattle's waterfront without the blight of the elevated highway. And so they put together a terrific planning and design team that has come up with a very innovative and realistic plan to make use of the additional sites along the waterfront. What went wrong? Early planning was not so good. There were some political problems, but the biggest problem, as I mentioned, was that Washington State lacked a contingency or backup plan in case something happened to Bertha, which was really the only boring machine in the world that could do the job. Despite Bertha's problems, this has been a very good project, and I give it a sort of 35 score, which out of all the available points turns out to be 73. I'm just going to mention 2 other projects very quickly and then get to my 7 lessons. In the book, we talked about London Crossrail, or the Elizabeth Line, as not being completed. It has since been completed, and so let me mention a few lessons from that. This is the Elizabeth Line. Many of you may have taken it if you've come from Heathrow and gone to downtown or to Canary Wharf. It was built so that London would maintain and improve its advantages as a world financial center. So it was designed to do exactly that, to move businessmen who landed at Heathrow Airport downtown to either Paddington Station or Tottenham Court Road, which is sort of the center of London, or Liverpool Street, which is the center of the business district, and finally over to London's second CBD, Canary Wharf. And it was really the first deep bore tunnel in London, which means, again, it wasn't cut and cover. They needed deep boring machines to build it, which they hadn't done before. It was really meant to be a game changer. Down at the bottom, you can see some of the travel time savings. So if you wanted to go from Paddington to Tottenham Court Road, many of you may know these places. I think of them very fondly. Shorten the travel times from 20 minutes to 4 minutes. If you want to go from Canary Wharf to Heathrow, it shortened the travel times from 55 minutes to 39 minutes. If you wanted to go from Bond Street to Whitechapel, it shortened the travel times to 24 to 10 minutes. Right. So in terms of travel times, it's really a game changer. It was projected to cost about $15 billion, ended up costing about 30% more than that. It was planned to open in 2018. It took an extra 4 years to build. What went right? I'll talk about this a little bit more. The government had an excellent project evaluation process that really allowed the project to go forth only after it was able to finance itself and made both market and financial success. The idea of shortening travel times as a way of improving business competitiveness and financial competitiveness made a lot of sense. And the tunnel boring program worked very well. What went wrong? A number of things. The project managers were in love with the idea of being innovative. So they, instead of the usual hierarchical project management process, they put what's called a matrix model in place, in which contractors are supposed to coordinate with each other rather than with their bosses. That never worked. There was an overemphasis on trying innovative management practices. Most importantly, each of the 10 new stations were constructed by different contractors who had no experience working with each other, nor did they have experience working with the new electronic signaling and train control systems. So they just ran up against problem after problem with the train control systems and coordinating them. Despite that, if you've been on it, it's a pretty successful system, even though it took an extra 4 years. And looking at all of its features, at least when we looked at it, it earned about a score of 32 or about a 67, putting it sort of squarely mid-pack. I'll just very briefly talk about 2 airports, Berlin-Brandenburg, which is the Berlin International Airport, and LaGuardia, I'm sure many of you have flown in and out of LaGuardia, which isn't a new airport, but was an upgrading and renovation of Terminal B, which was just probably the world's worst airport. In fact, in 2016, both Joe Biden and Donald Trump flew through LaGuardia and both commented publicly that it was probably the world's worst airport, the only thing they ever agreed upon. So just they took the two sponsors. In Berlin's case, it was the state of Brandenburg and the state of Berlin, and in New York's case, it was the Port Authority of New York and New Jersey. Took absolutely opposite approaches to it. The Port Authority had a long-standing relationships with contractors and a long-standing way of building airports and improving airports, and had a very good public-private partnership model already in place that they could rely on. And the states of Berlin and Brandenburg had no experience whatsoever building airports. And when an early effort to put together a public-private partnership failed and then failed again, they said, well, even though we don't have any experience building airports, we'll be the project manager. So you had a bunch of government officials who had no experience with major transportation projects taking on the job of the biggest airport project in Germany's history. And they failed again and again and again. You can see a comparison here. The Berlin-Brandenburg Airport approval was actually given in 1999, and it was supposed to be finished in 2010, ended up being finished in 2020. It was originally planned to cost $2.2 billion, to end up costing $8.2 billion. If you ask the question, who'll do a better job developing airports, a bunch of German engineers or a bunch of New York blowhards, you would have said the German engineers every time, but it turned out to be the New York blowhards. I'm not sure they're blowhards. Approval was given in 2016. Construction was planned to be finished in 2021, and that's the way it went. The budget was $4 billion, and it ended up costing $4 billion. What went right and what went wrong? Well, everything went wrong in the Berlin case, mostly based on the lack of project manager experience. What went right in the LaGuardia case? Well, again, the Port Authority had really good experience doing this type of project in both design, construction, engineering, and particularly in financing. And they really were able to make use of that experience. Berlin earns an 18 or 38% score. LaGuardia earns a 35% or 73% score. By the way, of the 13 groups of projects that we looked at, the Berlin-Brandenburg Airport was not the worst. That was the Hong Kong-Macau Zhuhai Tunnel. That did even worse on a bunch of things. And LaGuardia wasn't the best. That was Singapore Changi Jewel Airport Terminal, which got close to a perfect score. So let me just conclude with my 7 secrets of project success, mega project success, drawing on both examples I've talked about here, other examples in the book. Most important thing, project manager competence and experience matters above all else. There's just no substitute for having done similar projects. Doesn't have to be in the same context, but similar projects. Singapore's Airports Authority has had long experience developing their airports and others. And as I talked about, the folks in Berlin had no experience, and that's why they failed. Project managers should carefully study past projects to learn from experience. Again, Singapore has institutionalized learning into their system. In the history of bus rapid transit, there's also terrific knowledge transfer from one city to another that's made BRT a success, particularly in South America. A failure in this regard was Brooklyn Bridge Park. Standardization, I've mentioned that, can be extremely important for cost efficiency and timely delivery. China's approach in both on high-speed rail and city metros has been terrific. I mentioned Crossrail, or the Elizabeth line, was the opposite of standardization. Every station was designed differently. Senior project management should be knowledgeable, capable, accountable. Hoffen City is the exemplar here. London Crossrail, not so much. Key market assumptions and budgets. Key market assumptions and budget schedules need to be stress tested. London Crossrail did a good job on that. I mentioned the Hong Kong Zhuhai Macau Bridge as not doing so well, and this is where they fell short. Their theory of why the bridge was needed was based on the idea that lots of people, first from Hong Kong, lots of people from China would want to gamble in Macau, and that they would want to go through Hong Kong and then drive there to Macau. They didn't foresee that you would be able to fly directly to Macau, and there were also other issues. Develop contingency scheduling and financing plan for the worst case scenarios. Again, LaGuardia did it tremendously, allowed them to stay on budget with time. Seattle didn't anticipate that Bertha might run into problems. And lastly, look to make the transportation land use connection. Seattle has done very well with this on their waterfront development. London Crossrail has done very well on their value capture-based approach to financing the project. Curitiba Bus Rapid Transit, which is now 50 years old, was really the leader in connecting bus rapid transit with land use. Jakarta's BRT built the system as if the activities around it in terms of land use didn't matter, and has had disappointing performance. So I think there's a lot we can learn about how practice affects performance. It's not simply a matter that all mega projects will turn out badly, or that some will turn out well and some will turn out badly. I think there's really a lot of things we can learn by looking around the world at best practices and worst practices and connecting them to performance. So with that, I'll finish. Thank you very much for your time.
Great. Thank you so much, Professor Landis. Thank you for such a rich collection across the whole globe, the examples there. Maybe I'll start the first question on, given this high stake, right? Some of the projects often choose this proven practical method, right? But at the same time, you'll find the mega project is also the best opportunity to test the technology innovation, process innovation, right? So how do you advise the future mega project to juggle between the innovation versus practicality?
Well, I'm going to give an answer that may be a little controversial. I don't think governments, and to the extent that governments are the sponsors of mega projects, they should be in the innovation business. I mean, they should be in the innovation business in certain ways, like America does it through DARPA and things like that. But the idea of government telling private operators or private contractors how to innovate in terms of technology, I don't think that's a good approach. And I think London Crossrail is a good example of that. I think a better approach is for the government sponsors to create incentive and bonuses for the private contractors and private managers and say to them, okay, if you can do better in terms of operating or design or construction costs than the contract calls for, you're going to be rewarded to do that. We're going to give you incentives or bonuses. And that creates an incentive for the contractors and the designers and the project managers to innovate. And so I think innovation really belongs on the people delivering. That doesn't belong with the sponsor. That may be a little controversial. There are a lot of people who think that government is better at identifying innovative practices than the private sector or public-private partnerships. I do not.
Thank you. Yeah. The second one is, I mean, U.S. had been the leader of a mega project, as you showed, right? But somehow we have the sense that we just lost it. Over the time, are we able to learn here, right? Are we able to say, transfer this project, what we learn, to another project? So cumulative, as collectively as a whole, we can progress over time in this, right? It seems that all the new products coming from Asia, some from Europe, what can we help the U.S. industry as a whole to really learn and progress here?
Well, I think there are two things to do. The first of all is to look at the examples of Singapore and in the U.S. of the Port Authority of New York, where in Singapore, I would say what I call be like Lee, and in this case I mean be like Lee Kuan Yew, who was an avid student of success. Wherever somebody was doing something right, he said, "What can we learn from that?" at the top of the government. And then secondly, he tried to take those successful practices and institutionalize them in his government organizations, whether they were planning or environmental organizations or construction or airport organizations, by hiring people who were interested in pursuing best practices and actually developing their best practices and institutionalizing them. And so to a certain extent, I think the Port Authority in New York has done something similar. And I think that's responsible for Singapore's success and the Port Authority's success. In terms of removing impediments, I think what the US has done is it has a much more stringent environmental and impact review process than other countries, but it's not a process that focuses on outcomes or results. It's a process that focuses on just comment and process and transparency, sometimes not transparency, and citizen involvement. And I think it really needs to reform its environmental review process and its impact assessment process if it's to get back in the mega project business. An example of that is what Governor Cuomo did with the Tappan Zee Bridge case in New York, where he said, you can do all the impact assessment you want. I need a determination in a year from now as to whether we're going to build this or not. And if we are going to build it, what mitigations do we need? And that deadline really meant the Tappan Zee Bridge was a success. Not my favorite bridge, but as mega projects go, is a success.
Cool, thanks. Yeah, last question from me before I pass to John Moenzadi. So if you have all the power, etc., what are the new mega projects you would like to see happening?
Well, first of all, I think, let me just focus on the mega projects where I think government needs to get involved as either a funder or a sponsor, given both the growth of the US, the transformation to a clean energy economy that's necessary in the US, and where the politics are headed. So I think there are 4 areas of priority for the US government. First of all, a strengthened, higher capacity and more resilient transportation grid, if we're to have an electric future the way we want. A national bridge replacement and upgrading program. The accident in Baltimore Harbor was just waiting to happen. We really need to address those things on a comprehensive basis. An expanded improved airport program. Pretty much every airport in China is a pleasure to be in. That's not the case in America. If America is to stay competitive in terms of transport, it needs to upgrade its airports, most of which are in pretty bad shape. And lastly, I'm not a big believer in new subway and metro systems. There are some places where they make sense, but an example I didn't talk about. I think the suburbs are here to stay in America, and center cities are here to stay in America. And building new commuter rails systems and new subways is extremely expensive. And as we've seen in Latin American parts of Asia, electrified bus rapid transit systems can deliver a comparable level of performance at about 25% of the cost. So I would focus our transportation improvements on bus rapid transit.
Great, thank you. So let me give it to John for the question and answer from the audience. John, please.
Thank you, Professor Landis. We had a very active chat. I want to start out with a comment that John Wilson made, where he noted that the focus on standardization is very important. And you pointed that out with the Crossrail example. And I'm just reflecting on, I did have the opportunity to read How Big Things Get Done this summer. The book by Bent, I cannot pronounce his name.
No one can.
Nobody can. Famous Danish economist who's dug into this. And he focused on the word modularity. And so I wonder if you could if you see a distinction. So as I understand it, modularity is asking the question, why is it that solar panel installations actually tend not to have cost overruns, tend to be more effective? It's because solar panels are basically a bunch of Lego blocks that you can just snap together. In my mind, that's kind of this concept of modularity, whereas standardization can include that and perhaps some other broader concepts. I'm curious how you reflect on this concept.
Well, I actually have a review of Bent's book coming out in the Journal of the American Planning Association. I liked it a lot. I thought it was very concisely stated, very, very entertainingly written, good examples. I felt the examples were often cherry-picked a little bit to make his points rather than being representative. Ben calls this modularity, he calls it his Lego approach to building mega projects. And I think it's fine to think about mega projects as being done incrementally rather than all at once. I think there was sort of a natural experiment in China in terms of metro systems. So in some places, particularly Beijing and Guangzhou, metro systems have been built incrementally, line by line, improving things line by line. In other places, Shanghai and Shenzhen, for example, they've more been master developed as a network, master planned and master developed as a network. And the problem with any transportation or infrastructure project in China is getting reliable cost estimates of what they cost and things like that. So it's really hard to make exact comparisons. But from my understanding, there's not a lot of other people may have different data, but there is not a lot of difference in the two approaches in terms of either cost or delivery or speed. So at least in sort of the transit area, I'm not sure there's all that much advantage to sort of the Lego or modularity approach. Obviously, there are many types of projects like bridges that can't be built incrementally or tunnels that can't be built incrementally. I think when it gets when you come to urban development projects, incremental may be the way to go rather than taking on these huge projects. But that's mostly for the opportunities of learning and risk management. The two examples in the book are in Stockholm and in Hafen City, which is in Hamburg. Both of them took sort of a master planning approach conceptually to developing it. But when they actually went to develop Hammarby Sjöstad and Hafen City, they did it much more incrementally, which gave them time to do on-the-job learning and on-the-job changes. So I think when it comes to urban development projects, modularity is probably the way to go.
Excellent. Okay. I want to address a question that Ellen Partridge raised quite early, which is how do best practices for mega projects differ from those for smaller projects? Again, I'm reflecting on the How Big Things Get Done book. They use the example of a couple in Manhattan doing a kitchen remodeling project. And sort of, do you see a fundamental distinction between these super large projects and smaller scale projects?
Well, I think the major distinction is how they're financed. I think large mega projects have to be some form of public-private partnership, or in the case of, for example, high-speed rail in China, it's sort of public-public-public partnership. So just to assemble the financing that's necessary for a mega project, they need a partnership approach. As you get to smaller projects, you can have individual private entities take them on or individual governments take them on. I think that's the major difference. The other distinctions, like, do you need a really good project management team in both? Yes. Okay. Do you need a good financial model going in? Yes. Okay. Should you think about standardization opportunities? Yes. I don't think there are that many differences, but I do think in terms of sort of the organization of the financial sponsorship, there are some differences.
A question from Dongheng Li. Was the decision of these mega projects partly intended to alleviate the negative effects of the financial crisis? So by increasing social investment to create economic demand, thus promoting employment and economic outcomes. What's your view on that?
Well, that was clearly the case in China. China in 2008 was very worried about contagion from the global financial crisis, particularly from the United States, and basically said, well, you know, we plan to develop these 8 lines over the next 20 years. How about we develop them over the next 7 years? So they really doubled down on their construction plans. And that provided a lot of stimulus to the Chinese economy. I should say that it wasn't just high-speed rail. They did that on a lot of infrastructure projects, and that provided a lot of stimulus to the Chinese economy. I don't think it was responsible for the overheating of the property market that we're seeing now, or the after effects of that overheating. So I think that was a reaction. You know, I think in the I think the Crossrail case that had been planned well before the global financial crisis. In most cases, these were not reactive. They really were. These projects were not reactive. They really were an attempt to take a look ahead at urban infrastructure needs and think about how to do them from a systematic or a all-at-once approach.
A question from Seamus Joyce Johnson. Can you speak to the role of the consulting industry in sapping in-house government expertise in the United States? As you pointed out, China, Spain, high-speed rail systems have benefited from building up expertise and standardization within the government bureaucracy.
So it's a really great question. I'm not sure I would put it that way, but historically, what made the Hoover Dam such an important thing was that the contracts for the Hoover Dam created the 6 big construction companies, like Bechtel and things like that, that would dominate the U.S. infrastructure business for the next 60 years. And those 6, Knudsen Morrison and things like that, internal to those companies, there was an incredible amount of expertise and knowledge. Okay. And those companies continued working right up through the construction of the interstate highway system, right up through the construction of BART and Metro and things like that. But after the 1980s, for a bunch of reasons, federal contracts for big infrastructure projects really tailed off. And a lot of those companies, that knowledge and that expertise was really lost. And so, and you see that, so that by the mistakes that were made on the Big Dig, if the Big Dig had been started 20 years earlier, the companies that did it would not have made those mistakes. So you really see there is a danger of knowledge and expertise falling off. And that's what happened in the United States in the 80s. It hasn't happened in Singapore. We'll see if it happens in China. That's a really interesting question.
Super, thank you.
Yeah, so it's 1 o'clock. I hate to cut into here. Professor John Landis, thank you so much again. This is really brilliant.